Hello everyone, welcome to our next biochemistry lesson. And now we will start by solving a problem about amino acids, and our problem will be we will have a long molecule composed of amino acids, and we will find its net charge of this molecule at different pHs. So now first of all, let me just take the question itself. And let me try to explain how we can do this. Now, the question itself asks us, this is the A part, and it asks us the net of the molecule at pH equals to 3, 8, and 11. What's its pH? Now, how do we do that? First of all, there is something that we shouldn't forget. This something is that we have the N-terminus. And here we have the carboxylic acid. Sorry, let me write it here, C-terminus. And now we need to find the pKa of these values, N-terminus here, and we have the C-terminus here. Now we will check out all of the values which are given in the throughout the notes, and we need to find this. Now, in order to do so, we will be doing an analysis in the tables. And now, what is this? This might be glutamic acid or glutamine. However, glutamine is abbreviated as GLN, as we have the emphasis on the nitrogen over here, but this is GLU, means glutamic acid, all right? And therefore, we will find the pKa of the glutamic acid first of all. Let me tell you, the pKa of glutamic acid is the N-terminus of it is 9.48. We have 9.48. And what is the side chain? Side chain's pKa, it is 4.07. And let's go to histidine. What is its pKa of the side chain? It is 6.10. And let's see tryptophan. Tryptophan has nothing, no acidic nor basic side chain. Therefore, I just put a dash on there. Serine similarly has no acidic nor basic side chain. And then we have glycine. Glycine has similarly same. We have leucine, and then leucine. Let's see if leucine has pKa of side chain. No. We go to see arginine, and then arginine is has a side chain pKa 12.48. We have proline. Proline is also similar to previous examples. We have glycine. Glycine has no pKa in side chain, and its C-terminus instead. Meanwhile, its C-terminus of glycine, we can of course find that as it has a C-terminus as all the amino acids, and it is 2.35. All right, now knowing this information, we will analyze our question. And it asks us what's the net charge of the molecule at pH 3, 8, and 11. At pH, when the pH is 3, we will make a small analysis. So the N-terminus is of course basic. So when pH is 3, it will react, and when this is the reaction of an acid. So since this is a base, the N-terminus is a base, it eventually will, this is the way an acid goes, and this is the way a base goes, all right? And therefore, it will take an hydrogen atom. This base will take an hydrogen atom. What does that mean? Since a base takes an hydrogen atom, and hydrogen atom is positively charged, we will write as +1 as its charge, all right? And then we have the glutamic acid, the side chain. Side chain is of course an acid, as its name suggests. And however, as we can see, the pKa of this one is 4.07 and our pH is 3. Does this mean that it will give out an hydrogen? No, because the matrix itself is already so acidic that it won't allow glutamic acid to give out its proton. Therefore, glutamic acid won't be able to deprotonate. However, will it protonate? Of course not, as this is an acid. We cannot add any proton on it. So therefore, we can basically say that its charge will be 0. Plus histidine. Now, histidine, I know that it's written 6.10. However, we must pay really close attention to this part, because there's a key concept. Like, it's really probable that a lot of students will think, well, it's an acid, so as its pKa is smaller than 7. However, the pH is 3, so smaller than its value, and it will have 0 charge. But no, this is not the case. We should know that histidine is a basic amino acid. As its side chain, I'm drawing histidine over here, and histidine has the amine group, the carboxyl group, the hydrogen over here, and its side chain. Pay really close attention, please. And here we have a double bond, and then we have an NH over here, an H positively charged, and then we have another double bond, an H over here. So what does that mean? This is a base, ladies and gentlemen. This is a base, and therefore, since we are putting this in an acidic solution, we are going to obtain a positive charge, as the base will get protonated. All right, this is our answer. And then let's see in arginine. Arginine is of course a base, and let me tell you even more, its side chain contains 3 nitrogens, so it's of course a base, and it will get +1 charge. And here the C terminus means carboxylic acid, so it's acid. All right, and then its pH is 2.35, which means that it's really acidic. Even though the pH of the matrix is 3, C terminus tells that it's really acidic, so it will give out a proton, making it negatively charged. So what do we have at hand? We will have +2 as our answer. So what is the case in pH equal to 8? Let me see. So when pH equals to 8, the N-terminus, what will happen in N-terminus? N-terminus is a base, and it is more basic than the matrix. So we basically think the greater the pKa, it's smaller the acidity and bigger the basicity. So greater the pKa, greater the basicity. Therefore, this is more basic. 9.48 is more basic than pH equals to 8. Therefore, it will get protonated, giving it a +1 charge. And then similarly, we have an acid over here and then a base. These two will react, and what will happen? The glutamic acid will give away its proton, making it -1 charged. And then let's continue. Here we have a base, but it's less basic than the matrix itself, so nothing will happen. And then we will have a base really basic, which have a very high pKa of 12.48, which means that it will take a proton from the environment, making it positively charged. Okay, let me rewrite this because it's really nasty over here. Okay, and then lastly we have an acid, which means that it will give out a proton, making it -1 charge. And here, let's add up all the values and we will get 0, which means that we are really close to Pi. All right, let's continue. If we have pH equal to 11, now what will happen? 11 is really basic. So this, even though it's basic, it's it won't be able to make anything at any move, so it won't be able to get protonated, as the matrix is already really basic and it gets all the hydrogens which are already in the matrix, so there's nothing in it for the N-terminus to get, and it will have a 0 charge. Alright, glutamic acid will give out its proton as it's acidic, but the matrix is basic, of course, and then therefore its charge will be -1. And then let's continue. Here we have a weak base and nothing will happen. And then we have a really strong base which will get a proton from the environment. That's why it will be +1 charge. And then we have a acid which will be -1 charge. And in total we have a value of -1. So our second question asks us to estimate the PI for this peptide. Estimate the PI for this peptide. All right. So how can we find it? What its PI will be determined by adding 2 of the pKs, which is 1 lower and 1 higher than the pH, which resulted in a 0 net charge. All right, 0 net charge, which one had it? pH equal to 8. All right, so 1 higher, which means we had 8 over here, 1 higher is 9.47, and 1 less is this one. All right, and then we are going to add these two together and then divide it. All right, let me write it over here. 9.48 plus 4.07 divided to 2. No, I haven't finished this calculation. And yeah, this is basically the result. You can calculate the rest. And then let's continue with our journey. And we will continue from the basicity of the guanidine group. Now, first of all, let me show you why is the guanidine group basic. All right, we already know that actually, and I will just real quick show you that. Here we are. We have the guanidine. And it has a group which contains many nitrogens. Sorry for the confusion. I was searching for guanidine as an amino acid which doesn't exist. The amino acid itself is called the arginine amino acid. If we remember the one shiny, we said silvery was shiny as we have cleaned it with soap, which is basic, and that was our little trick to remember that it was basic. However, I totally forgot, and now I remember. It is really important to memorize all the amino acids, as we can see here. And let me say arginine. What was arginine? So first of all, we had our carboxyl group, and we have our amine group, and then we have our side chain, which goes with 3 carbons, and then we have a nitrogen group over here, and then 2 nitrogen groups also. This is plus charge, this is like this. Okay, so the side chain of arginine contains the guanidine groups. This group is called the guanidine group. ladies and gentlemen. Now, how do we know that this guanidine group is particularly basic? So, if a group is basic, when it gets an hydrogen from the environment, when it gets it, it becomes really stable. It resonates so that it won't give this hydrogen back, so that it means that it is really a strong base. So how do we know that? Now, as we can see, we have just one hydrogen over here. So when we will get a hydrogen, it will duplicate this, all right? And our group will become NH2 like this. I've put in these two dots. This is because we already know that nitrogen has 5 valence electrons that I just completed them over there with adding 2 dots. And now I will just write an HR. All right, I have my 2 dots, and then we already had an H2 with a positive charge also before. And what happens is that these 2 dots can go to their bond just below them, and then since carbon can't make 5 bonds, this double bond will go to the nitrogen below, so that its positively charged will be neutralized. All right, and then what do we have here? We have the following structure. All right, since these 2 electrons are given back to this bond, you can see that the nitrogen previously had 2 electrons over here, but giving them to the bond, one of them is carbons right now. So nitrogen is actually now deficient, electron deficient, which makes it positively charged. All right, and now we have the NH2 and its valence electron, and it has no charge. All right, great. And now what does it mean? Now this time these 2 electrons might come over here, and then this bond similarly will go upwards, and then we will have a similar structure, which is R and H, and this time this nitrogen had positive charge, and we have a carbon over here, and H2, and then we have NH2 also in here. All right, sorry, I missed something over here. I just wrote positive charge without thinking, and this is our 3rd resonance structure. And if we make a workup step, which is basically adding some water to the medium, what happens is that we will get the hydrogen of the positively charged nitrogen, which is this one, and it will form us a hydronium ion, which will basically look something like this. And H2, and we have a valence electrons, and H2 valence electrons plus H3O. This is our this is our hydronium. All right, and the pKa of this is 12.48, which means very, very basic. All right, so now you can see the reason why it's basic, because we have total of 3 resonance structures, not 2, even 3, which means that these electrons are really very joyful going around to different nitrogens, and this makes them really happy, so that the hydrogen is really happy to go inside. And so this means that it is really convenient for this molecule, which is called the guanidine group, to get the hydrogen inside. And eventually it is really, really acidic, as we can see the resonance structures.